Hello and welcome to the FlowCytoScript analysis seminar series. In these lectures, I'm going to talk briefly about how to run through Carlos's FlowCytoScript. I hope that these are helpful. If we have questions that build up at the end, as roll through these things I haven't covered, then I'll add more in as we go. So this first one is just going to be an overview of where everything is and what you need to do to get started. So you should have access to a Dropbox folder called List and Flow Panels and Protocols. Inside this, you'll have your flow panels and protocols for each particular panel that you're going to run on each machine. You also have instructions here for different things like auto spill or the FlowCytoScript analysis. In here as well, we should be storing eventually FlowJo workspaces that you can use as templates for gating your data, which you will use later in the script for generating FCS files that you want to analyze. I'll be adding those shortly. All right, so if we go back up to the main folder here, you should see that there's a folder called FlowCytoScript analysis and also this Word document file about how to store your files. So this naming conventions that we have here in this are actually fairly important for allowing you to proceed well with the FlowCytoScript. So the way you name your files is going to save you a lot of trouble down the road in importing these into R and sorting them with the computer. So these instructions are here for a reason. So you want to keep the naming simple and quickly identifiable, and the name structures that you use to potentially sort the samples into groups should be adjacent to each other. So for instance, if you were going to sort based on tissue source, lymph node, or spleen, that needs to be in there. If you're going to sort based on genotype, that needs to be in there. If you've done something to the mice, like injecting them with tamoxifen that's relevant to, or treating them with, giving them the flu, that should also be in here. If you're, say, comparing immunized to unimmunized, that would need to be in the flow file name if you're going to sort in R based on that as a variable. The other thing that needs to be in here is the mouse name. This is the mouse name from MCMS. Every time you take down a mouse, you will get this information, and that needs to be recorded into our FCS file so that we can track back and in case there's anything funny going on. It allows you to measure genotypes, get the genotyping information from MCS, request alternate information, or see the mouse's parentage. All right, so that's enough for that one. We're now going to go into the FlowCytoScript, and here, for those of you that are new to R, you probably want to start with this Learning R section. You'll first need to download and install R. I would also recommend downloading and installing RStudio, which is what I'm going to be using for the tutorial. This is a lot easier to work with than R. It provides a nicer user interface, and you can have more things open at once in a tab structure rather than just multiple windows. Down here, you have some links. Abraham runs a bioinformatics course on learning R. That would probably be a good place to start. If you want to learn on your own, Swirl can be handy, or you can just start by running the script. You should be able to just run the script with my instructions without actually having to understand much about how R works. The way things are going, it's a good idea to learn some R. So you're going to download R. Let's just have a look at that quickly. So most of you are going to be downloading for Mac or Windows. For Windows, just keep in mind that there are different versions depending on what you have, 32-bit or 64-bit. So have a look at this. And then once you've installed R, you're going to want to keep it up to date. And you're also going to need to install the packages that are relevant for our project, which are the libraries of code. So I have installed R and RStudio. So in order to update R, we're going to go into R, and then if you don't remember how to do something, you can almost always find it in Google. Okay. So I've already installed this, so we can just type this in. And then you can see this newer version. We're doing this in R rather than RStudio. That's recommended. And so the important thing to keep in mind here is that there's 3 different numbers here in the R nomenclature. This small number, the N, is the version number that changes the least amount of the code. The middle number changes a larger amount of the code, and anything in the front end, like the 4, if that changed to a 5, that would be a large change, which means that potentially large fractions of the RStudio the FlowCytoScript that we're using might become invalid or incompatible with the new version of R. So certainly update it as long as you're staying within version 4. We can always go back to an earlier version if you have to. Right. So I'm going to update. All right, and that's done. And then we can copy over the packages. If you're new to R, you won't have any packages. And then it's going to ask you if we want to update the packages, and we say yes. That didn't work. All right, so we can go to update packages. You can also do update packages in RStudio, which is actually easier in general. And you can see that I haven't done this in a while because I've been working in the lab rather than on the computer. Okay, and that's done. So now we can close R, and when it asks you about saving workspace images, just say no. All right. So now we have R installed and up to date. We want to go to the FlowCytoScript analysis, and we have here the script. So you should have only read-only access to this file, so you shouldn't be able to modify it, but you should be able to copy it. And the first thing you're going to want to do is create a directory in your computer, a file structure where you are putting all of this in a way that is organized. So what I have, and you might want to copy, is folders where you start with 0, 0, 0, 0, 1, so on, so that these are always arranged by name alphanumerically. So we create a separate folder for analysis from one for data, inside my analysis folder, I have individual folders for each experiment. Similarly, in the data, individual folders for each experiment, which are named by the date and the type of the experiment. For the CytoScript, you're going to want to put that in a particular location and then not move it. So I put it here, and you can see that I have 00 source. This is what actually contains the scripts. This here is an example data set that you can run on human brain versus blood. So PBMCs are blood. So these are the actual FCS data files. And here you have the analysis output from that. You can have a look at it and have all these UMAP plots. So this is what things more or less should look like as an example output from the script. So let's say we make a new folder that is called FlowCytoScript. Then we would copy in our source. And then we might have a new folder that says analysis in here. And then inside that, we would have our experiment. So we'd say 2020, whatever the name of the experiment is, experiment 1, and so on. And then inside here, what we need to have for each one, or what I recommend that you do, is create a separate folder for data, which will contain your FCS files, and another folder for your output or analyzed the tSNE plots and so on. This is going to be useful later when we're setting the working directories in R, so that you don't get you don't create more work for yourself. The data is where you're going to put your FCS files from FlowJo. Output is where you're going to put your parameter file. The parameter file is here. So we're going to copy that and put it here. And I think that's all the topics I wanted to cover in this introductory session. No. All right, we're going to open this up. So just double click on this and it will open up in RStudio if you have RStudio installed. And there's an additional detail in here that you're going to need to know information about your computer. So where is it? Here. This is for parallel processing on your computer. So the number of threads, which is the number of processes that are running simultaneously. This is going to change on each computer depending on what processor you have. Mine has 6 cores, each of which is dual core, which gives 12 potential threads that can run. We don't run the tSNE script on all of them at once, because if you leave a couple open, then you can do other things while the tSNE calculations are running. Sometimes it takes a half hour, an hour to run, and you would like to be able to use the computer for something else. So usually use a couple less than what you have. If you only had 4 processing channels, then you might use 3 of them. So you need to find out about your computer. So in Mac, you can just go to About This Mac. In Windows, we go to System, Settings and System, and then About. And you can see that I have here this processor. So if we then go back to our friend Google and ask it, what is this processor? You can see right away we come up with the number of cores it has and the number of threads that it has. So you should be able to find this information about your computer figure out how many threads it has, and then change the variable here to adapt this to run on your computer. Once you've changed that, you just save it, and then any changes like that that you make, you should be able to just use your local copy that you've already modified as a template for your next experiment that you analyze, rather than going back to the original one in the FlowCytoScript folder on Dropbox. All right, and we'll continue on with the next segment, which will be talking about how to get your data from FlowJo and put it into our